lowest common multiple. Okay. So likewise in primary school, right? Okay, when we want to find the lowest common multiple of, let's say, the numbers 4 and 6, we also do by listing, right? Okay, so we look at the multiples of 6. Multiples of 4 and the multiples of 6. Then we actually list all of them out, okay, and then find out whether there's any smallest one itself. So we have 4, 8, 12, 16, 20, 24, 6, 12, 18, 24, and so on. Okay, so from the list itself, we will then see what is the common one and the smallest one, and that will be the number 12. Okay. But there are times whereby it is not so easy, whereby the common multiple doesn't come in so early, okay, in the series or in the sequence that we have. Okay, so therefore, we also want to have a more efficient method in finding out our lowest common multiple. Right? So let's look at practice now 12. Question 1. Factor. We have two methods as well that you could use. Method 1 is by your prime factorization, where we express each number into its prime factors and its index form. Okay. So looking at the number 24, we figure out what are these prime factors by making use of this ladder. So 24, I will first divide by 2. I'll get 12. Next, we divide by 3 already, so fast. 2 again, right? Okay. And then we can do 2 again. Then finally 3. Right? So we will have 2 to the power of 3 times 3. Okay, that's for 24. And then we do the same for the number 19. Then what does this one day represent? Can you erase it? I thought like maybe you all don't know who is Monday. Okay. So 19 divided by 2, 45, divided by 3, 18, divided by 3 again. Okay, so we can break down 19 into 2 times 3 squared times 1. So now, we get this so far. Okay, now LCM, how do we find it? Okay, we know how to find highest common factor already, right? Okay, for highest common factor, we were looking at what are the factors that are in common. Okay, they must be in common first, then I can take out the lesser of it. Remember that? Do you remember highest common factor? Okay, so now lowest common multiple. Let's break down this idea first. Okay, lowest common multiple, the idea is multiples. Multiples means that it must be from this number, we count towards the next one. So from 24, the next multiple will be 48, right? Okay, then after that we go on to the next one, that will be 48 plus 24, so 4, 5, 6, 72, right? Okay, so it will be, if I were to list it out, it should actually go in 24, 48, and 72, and so on. Okay, whereby 48 is I take this number, 2 cubed times 3 is equal to 24. Okay, I times 2, right? Then I can get 48. Then 72 I times 3 to this number, then I get this one. And then I times 4 times 5 and so on. 90, likewise, if I go down the same idea, 90 is the first one. Next one I'll get 180. Then after I get 270 and so on. Agree if I were to list it out. Okay, so we get an idea of multiples. Okay, next thing, LCM, right? Common. Okay, we want to see where is the common one, and then we want the lowest one as well. Okay, so what this means is that in our selection over here, between 2 cubed and 2, okay, our lowest common multiple must have within it the number 24. Must have within it the numbers over here. So therefore, I will take out the highest one, 2 cubed. So between 2 cubed and 2, I will take the highest one, 2 cubed. Okay? Because 24 must be within the 24. Otherwise, it is not a multiple one. Just like 48 and 72, within it we have 24. 180 and 270, within it we have 19. Okay? So we take the 2 cubed. Next one, between 3 and 3 square, okay, we also take out 3 square, the highest one, okay, because if I take the highest one, the lowest one will also be inside already. Do you agree? Okay, so therefore we take 3 square. Right? So as long as we take the highest, the lowest one will be inside. Okay, and for the 5, okay, 90 has a 5, 24 doesn't have a 5. But because we're looking for multiples, okay, the 5 must be included. Otherwise, this lowest common multiple doesn't have the 90 inside it. It wouldn't be a multiple anymore. Okay, because multiple means that this number I can divide by 90, I can also divide by 24. Right? If I don't have the 5, this number cannot divide by 90. You can go and try it out. Okay? Alright? So when finding lowest common multiple, we always take the largest number. Okay, even if don't have, we still take. You understand what I'm saying? Okay, so let me write down. Okay, so take out the factor that is of largest. So that means 5 down here don't have, but down here have, 5 is still the largest one we take it. Okay, you can press this into calculator. We have 8 times 9, that's 72 times 5, we have 360. Okay. Right? Okay, so that's by doing prime factorization. Okay. Right, so to end here for today, let this go and sink in your mind, go and think and ponder about it. Tomorrow we'll come back, okay, and talk more about this as well. Okay, we're going to look at the method 2, ladder method. Okay, so in our ladder method, what we'll be doing, okay, to find the lowest common multiple, sorry, I forgot to write the question, find LCM of 24 and 90. So to do the ladder method, what we'll do is to have our framework in our ladder in place. We'll place our 24 and 90 on it. Okay, so in our ladder, what is the first number that we'll divide it by? 3. Is that the smallest one number? 2. We also have 2, right? Okay, so we'll do 2, 12, 45. Okay, what is the next prime number to divide by? It will be 3. We have 4, 15, okay, and then, is that all? Okay, that's all right. So yes, so similar to our highest common factor, we stop when there's no other common prime factor. Okay, so since the question says smallest, we link it with lowest common multiple. Okay, so therefore we should be able to observe and conclude that we are looking for the LCM in this question. Okay, now something important that I want to bring your attention to is regarding the word hence. Okay, the word hence is very important because there's a certain instruction that follows with hence and expectation for it as well. Okay, so in mathematics, whenever you see the word hence, what they are expecting you to do is to make use of the information that has been given and to answer your question. Okay, so you must use the info given to answer the question. In this case, the information given to you is the numbers already in its prime factorized form. So you must only use the prime factorization method to solve this question. Okay? What if you choose not to do the prime factorization method and even if you get the correct answer, you do not get a single mark? Okay? Because the method itself is not correct. Alright, so this is an important thing to take note. Okay. So using our prime factorization method, looking at the numbers over here, to find out the lowest common multiple, okay, let's do a very quick recap. Okay, what should I be taking out from 120 and 106? Okay, we have 2 cube and 2 over here. How many 2's do I take out? Yuki? Between 2 cube and 2, how many 2's do I take out? 3. Okay, so recall that in lowest common multiple, we look for the numbers that are listed over here, okay, and then we take the greatest one. Okay, we always take the greatest one that is actually seen in both numbers. Then for 3 and 3 squared, okay, what should I be taking out next? Generally. Sorry, now where is generally? 3 and 3 squared, how many 3's do I take out? Just like I mentioned, we take out the highest one. So between the 3, we take out 2. Okay, so 3 squared. Okay, then for the 5 and the 7, we see that down here has no 5 and down here has no 7. Okay, we still need to take it out. Okay, so we need to include the 5 and 7. So we choose the greatest that has been found. Since down here has none and down here has 1 of it, okay, we will take out the 1, right? Because 1 is bigger than none. Okay, questions? So, keying this into your calculator, we get 2520. Okay, so that's the lowest common multiple. Listen to book. Okay, questions? If not, let's take a look at practice now 30. So let's do the first method of prime factorization first. Okay, for this method, we look at the numbers 9, 30 and 108. We want to express it into its prime factorized form. For 9, I think it's straightforward. Not much need for us to do the ladder. 9 is equals to what? 3 squared, right? Okay, what about 30? Okay, 30 maybe you want to do out the ladder. And you'll get 2 times 3 times 5. Okay? Wait, okay. and then 3, 3, 3. So we get 2 squared times 3. Okay? So with the prime factorized form already, what will the LCM be? Ian? Where is my Ian now? Okay, yes, Ian. What do I take out? 2 squared, okay? So notice that down here we have 2, but there's 1, 2 and 2 2's over here, we take out 2 squared. Okay? What about the next number? What do I take out? Danish. 3 cubed, okay? Wait. Any more that I have to take out? Joshua, what do you think? What do I stop here? No idea? Be a guess? We stop here? Okay, how many of you think we should stop here already? For our lowest common multiple? Oh, disagree? Okay, alright. So earlier on I mentioned that when we're doing prime factorization, okay, for lowest common multiple, okay, even if the others don't have, we must still write down that factor itself. Okay? Maybe I explain why is that so. Okay? Because you're looking at lowest common multiple, right? Okay? Multiple, what does it actually mean? Starting from 9, we're looking at the next number, which will be 18. Okay? Then after 18, that will be 27, right? Okay? And so on. Okay? For 30, we look at the next number, 60. Then after 60, then 90, then 120, and so on. Right? For 108, likewise, okay, we also go down the list. So maybe let me just write that down. Okay, we're looking at 9, 18, 27, and then 30, 60, 90, 108, 216, and so on. Okay? So if I were to proceed with listing it out, I want to find the smallest one that is common amongst what we call these numbers multiples. Okay? Since I'm looking for lowest common multiple, that means the eventual number that I'm going to get, okay, must be able to divide by 9, must be able to divide by 30, must also divide by 108. Agree? Okay? This number must divide 9, divide 30, must divide 108. If cannot divide, then it's not called a multiple anymore. Right? Okay? So therefore, if I don't have the 5, okay, will this number still be able to divide by 30? No, right? Because my 2 square, yes, I can divide by 2. 3 cube, I can divide by 3. But I'm short of a 5 over here. I cannot divide. In the end, my number cannot divide by 30. Okay, so for example, if you don't see what I'm trying to say, okay, let's say if I calculate this out, what do I get? 4 times 27?
4 times 27.
108. Okay, I think 108. Okay, I divide by 30. Can divide or not? Cannot, right? Okay, so I need this 5 to be over here. Sorry, for marker. Okay, I need this 5 to be over here in order for me to generate a number, okay, such that it will divide by 9, 30, and 108. Okay, because all these are factors, okay, prime factors itself. I need to have a number that can divide by all the things that are found inside here. Okay, that's why we always take the biggest one, okay, and then also those that are even not in the others, but we still have to take it out. Okay, so in this case, what we will eventually get is 540. Okay, so we always take the greatest when it comes to lowest common multiple. Okay, so in a very loose way of saying that, we take out the greatest factor. Any questions? Yes. Why is it 2 square and not 2 cube? Huh? Okay, where do you get the 2 cube from? Sorry? This one, you add them up together. So total got 3, is it? Okay. If you take total, right, okay, end up your number will not be a lowest common multiple. It will be a multiple but not the lowest. Yeah, okay? So if I let's say take 2 cube more, alright, what I'll be getting in the end is 1080. 1080, yes, can divide by 9, can divide 30, can divide 108. But it is not the lowest one. Okay? So that's why we take the pre-existing one. I don't need to go and count and add everything. Okay? Good question. 540, right? Okay? So let's look at the ladder method, method 2. Ladder method is a little bit trickier when it comes to 3 numbers. You need to memorize or rather remember how it actually works. Okay? Somewhat similar to the highest common factor. So I also place the 3 numbers on this side of the ladder. Okay? I will also look at the 3 numbers, determine what is the common prime factor amongst all of them. What would that be? What can 9, 30 and 108 all be divided by? 3, right? Okay, so divide by 3, I'll get 3 over here, 10 and then 36. Right? Then between 3, 10 and 36, okay, what else can I divide by? Cannot already, right? Okay, so in our highest common factor, what we learn is that as long as all cannot, we stop there already, and then we go and find the highest common factor. Okay? But when it comes to lowest common multiple, we can only stop when 2 of the numbers no longer have any more common prime factor. So between 10 and 36, there's still a common prime factor of 2. Okay? So what I'll write is that 3 I cannot divide by 2, I'll keep the 3 over here. Then I proceed with dividing by 2, 36 proceed with dividing by 2, I'll get 18. Okay? But then 3 and 18, I still can divide by 3. I will get 1, 5, and 6 over here. Okay? So, in the ladder method, what we need to take note of is that stop when cannot, when there's no more, we rephrase this. Okay, when there's no more common prime factors between any 2 numbers. Right? Similar to when we were dealing with the 2 numbers one for LCM, you will go in an L shape still. Okay. Hence we have 3 times 2 times 3 times 1 times 5 times 6. Answer comes out to be 540. Any questions? Oh yeah, I see that you're not really copying anything. Sorry, say again. take a look at practice now 15. Okay, that's in your textbook page 22. Do write it down, okay? Because all these are important. Okay, now as to question 1 here, we have to find the smallest value of n such that the lowest common multiple of n and 15. So the two numbers that we're looking for the lowest common multiple is n and 15, and this lowest common multiple is 45. Okay, so if I follow the same structure as when I was doing my prime factorization, I identify the numbers, okay, then after that my LCM is always at the bottom. So let's keep to that structure, okay. Now for the value of n, right, okay, we clearly don't know what is the value of n, that's what we want to find, okay. But for 15 itself, if I want to, I can do my prime factorization. Okay, in fact, sorry, not if I want to, but you need to do your prime factorization, and 15 will be 3 times 5. That one's straightforward, right? Don't really need to do this lengthy stuff. Okay, now 45. Okay, how do we usually get 45 for our lowest common multiple? We always have to list it out in this manner first. Okay, so what this question is wanting us to do is to work things out backwards. Okay, so for the number 45, right, usually it is at the bottom. Okay, so what do I write as its prime factors form, prime factorization form? Okay, I will do 45, divide by 3, I'll get 15, divide by 3, 5, 5, and 1. So I will have 3 squared times 5. Agree? Okay. Now this is the part where I want you to follow me first. Okay. If you cannot copy and cannot write and listen at the same time, then I want you to pay attention. Okay. Now, lowest common multiple is 3 squared times 5. We said that when it comes to prime factors, what we take out is always the highest one. Agree? This is a 3 squared. That means between n and 15, we have taken out the highest one such that it is 3 squared. But this is only a 3. That means 3 squared must be found where? It must be found inside n. Okay? Agreed about this? Now this 5. Okay? 5 needs to be found, okay, in as the highest number, okay, between n and 15. Over here, there's already a 5. Do I need a 5 over here?
No,
not necessary, right? You can also not have. Okay? Not necessary. But then, when is it that we will then determine what is the value of n? This question asks for smallest value of n. Okay? So the 5 is optional to be placed inside. But since I'm looking for the smallest n, that means that should I put a 5 inside? I shouldn't. Okay, so therefore, my smallest n, answer the question, will just be 3 squared and it's 9. Okay, any questions? Kiman, you understand? A bit frowning. Are we all good with this? Anybody don't follow what I'm trying to say? Yeah? You can copy that down. question 1. The question now says that the LCM of 9, 12 and K is 252. So let's follow the same structure. We have 9, 12 and K. Okay, our LCM will actually be 252. Okay, so earlier on we find out what is the prime factorization of all these numbers, and then we work backwards to find out what is K. Right, I'll give you about 5 minutes to go and work this out. Okay, find out what is the value of K. Okay, no need to check yours. Come back here, check yourself. Okay. Carry on, reconvene, looking at the whiteboard. Okay, let's look at the whiteboard now. Okay, 9, we know there's 3 square. 12, okay, we know it's 3 times 4, 2 square times 3. Right? Okay, so I hope that you can realize that sometimes, okay, there are certain numbers that are manageable. You don't really need to go about doing out your ladder itself. Okay, but if the ladder helps, then by all means use it. Okay? LCM 252, what is its prime factorized form? Could someone give it to me, please? Sorry, wait, I find the answer first. Okay, let's try to music. Okay, let's choose someone. Ricky. Okay, give me 252, it is prime factorized form. 2 square times 3 square times 7. Okay, great. Do we all at least have this? Okay, so now we want to find K. The question never even say if we want to find the smallest possible or the largest possible. Okay, we only just want to find the possible. Okay, and then also K is actually odd. Alright, so we need to take note of this, and also we want to find all the possible. Alright, so now we work backwards. Okay, now first question. If it is odd, can K have any factor of 2 inside it?
No.
No, right? Okay, because once there's a factor of 2, what will K become? It must be an even number already. So, cannot have 2 at all. Okay? Cannot have 2. Yeah, just write it. Like that. 2's are all impossible. Don't care is it 2 square, 2 cube, 2 whatever. So long as the 2, not possible. Okay, so then it falls back to 3 square and 7. Right? Let's look at 3 square first. Down here is a 3 square already. Okay, what does this tell us about K? Does K need to have a 3 square? It may or may not. Right? So the 3 square is dependent. Okay? You can have 3 square, you can have 3. Okay, I'm just writing another possibility. Or you can have no 3. You follow what I'm trying to say? Because for us the 3 square over here, we take the largest one out of the 3 numbers. And out of these 3 numbers, 9 already has a 3 square. So this 3 square can be safely taken from here. I need not have my K to have 3 square. Okay? So my K itself, in fact, I can have 3 square, I can have just 1 3, or I can have no 3 at all. We go with this part. Okay? Next one, look at 7. Okay? 9 and 12 has no 7 in it. What does this mean about K? We must have 7. So 7 is a must. Okay? So therefore, all my possible values of K will have to be 3 squared times 7, 3 times 7, or just 7 itself because no 3. Okay? So I can simplify this. 9 times 7, 63, 21, 7. So that's how we determine the 3 different possibilities. Okay? Any questions? Okay, let's just end off with one more question for the day. Ernest hate orange copying. Okay, Ernest? Or are you changing long-sightedness to short-sightedness now? Is it not evolution?
Both-sightedness, Pokemon evolution.
Okay.
The best way is to just get glasses.
Alright, let's do this. Okay. It says HCF of two numbers is 245. The question never give you what are the two numbers. Okay. So let's just let the two numbers be A and B. Okay, I don't know what are they. Alright. Question saying HCF is 245. Okay. So yeah, let's go 245 here. And 245, okay, I'll just skip through that tedious process of doing the ladder method. 245 is actually 5 times 7 squared. Okay, I leave this step for you to do. Okay. LCM is actually 4410. That breaks down to be 2 times 3 squared times 5 times 7 squared. Okay, so we need to now figure out what are the two numbers. Okay. Okay, let's start out with the highest common factor first. Highest common factor, we know that with A and B over here, they must be found in both of it, right? Okay, so 5 times 7 squared must be found in both numbers in order for my highest common factor to be 5 times 7 squared. I can have more of the 5s, I can have more of the 7s, that's possible. But minimally, 5 times 7 squared must be in both. Agree? Okay, now we tackle the lowest common multiple. Okay? Lowest common multiple, we already see that the 5 times 7 squared is already inside my A and B. Okay? So not a problem for this 5 times 7 squared. I can ignore it already. The thing is this 2 times 3 squared. Okay? 2 itself, okay, let me put out first. 2 itself, okay, can either be inside here, 3 squared can also be either inside here. Okay? But I need to separate it out. Why? Because the question says both numbers are greater than HCF. That means A and B must multiply with something else. Okay? So this one can be 2, this one can be 3 squared. Or else the other way around also okay, it doesn't matter. However, I want to point out that it cannot be 5 times 7 squared times 2 times 3 and 5 times 7 squared times 3. I cannot separate out the 3 into 2 different parts. Because we know that for LCM, if it is this way, then the LCM that I'm taking out will be 1 3 only. It cannot be 2 3s. Because we take out the greatest. Right? So this is not possible. So since there are 2 numbers over here, one of it I give A, the other one I give B. Okay? So therefore, okay, the 2 numbers are I will go and calculate my calculator. There will be 490 and 2205. Okay? Questions? Alright? If still not following this, I want you to go back and read through it and try to digest this. Tomorrow, when we come back, okay, if you're still not here, you can ask again in class. Okay? Jude, can you help me stop the camera, please?